Welcome to the COVID-19 Researcher Spotlight Series. Today, we are speaking with Todd Camenisch, Professor and Chair of the Department of Pharmaceutical Sciences at St. John Fisher College in Rochester, New York. Todd has been spearheading wastewater surveillance testing at the institution, and we will discuss how the program works and how results are guiding the precaution and mitigation efforts, as well as further testing. Thanks so much for joining me today.
Yeah, it's a pleasure to be here. Thanks for having us.
So, Dr. Camenisch, could you tell me what are the benefits of surveillance testing?
Yeah, the surveillance testing looks at the population or a population and can give you an early warning sign for potential outbreak of an infectious disease. And of course, in this case, we're talking about SARS-2 or COVID-19.
Absolutely. And you're helping lead surveillance testing program at St. John Fisher College. Could you tell me how that program works?
Yes. So it's a multi-layered surveillance program. So we start with a broad surveillance with a wastewater surveillance program where we collect wastewater sludge from 6 to 7 sites. And this is to surveil our residential students in the dormitories. And so those sites represent 8 dormitories. So we test that twice a week for the detection of SARS-2. And if we receive a signal over a certain threshold, then it activates or triggers the next level of surveillance. And that's where we employ the saliva-based testing. And so depending on the dorms that are within that catchment for the wastewater surveillance, we will have pre-printed barcoded collection bag kits with barcoded tubes that residents will provide to saliva. And then it's that saliva that is our sample that we use the LAMP PCR assay to detect SARS-2 in each individual resident. And then depending if they're positive or not, if they're not, then they're released from quarantine. If they're positive, they'll go into isolation. And then the next final layer, the third layer, is that they will get a nasopharyngeal swab done by the county health department to confirm the presence of COVID-19.
And how many times have the wastewater levels triggered the individual-based testing?
That's an excellent question. So in the fall, we had 6 or 7 events that triggered the saliva collection step and NP step.
How is the wastewater tested? Is that tested by the LAMP assay as well?
So the wastewater we collect and then we decant into transport tubes. And a group out of Syracuse University spun out a company and they perform all the separation and testing through qPCR. So that does not use the LAMP assay. They use the standard qPCR detection for it in the wastewater.
And are they using that because the limit of detection is lower for PCR as opposed to loop-mediated isothermal amplification?
Correct. Yeah, it's that it's more sensitive, and they have it set up for throughput. Basically, we're in a consortium with a handful of other colleges and universities in the region. And so just like anything, if you're running it routinely, it's a well-oiled machine. And so it's worked more effectively than us having to juggle at 2 or 3 times a week. And that allowed us to focus on that LAMP assay.
And so how frequently is the wastewater being tested?
So we have it set up for twice a week. And the setting up is also very important because you would like to avoid times when cleaners or sanitizers are being used in restrooms, toilet bowl cleaners and stuff like that could affect obviously the viral load that's being down into the sewer water sludge. Also, you want to have a catchment or collection period of time where there's high use. And so we switched from doing manual collection to where we use 24-hour auto samplers. And so we would collect over a 24-hour period, say Sunday evening until the following Monday evening. And the 24-hour samplers collect like every 15 or 20 minutes. So you get a nice sampling in that 24-hour period. And we do that twice a week.
Yeah, that makes sense. And then when you've identified a set of dorms that needs to be tested on an individual basis, your lab is performing those saliva-based lamp assays?
Correct. So if we have a signal, we already do the upfront work where we have the collection kits and bags prepared. So they're barcoded for each individual student. And so a collection kit in a bag would have the student identification, which is the barcode identification. And inside that collection is the saliva collection tube that has exact same barcode on it. Then there's a smaller tube that's in there that has the stabilization buffer with proteinase K and some sodium hydroxide to neutralize the acidity of the pH so it doesn't impact the lamp assay. And an alcohol wipe, so when they're done providing the sample and pouring in the stabilization buffer, they wipe the tube down and they put it back in the bag. And then we have a team with safety and security and residence life that goes around, collects all the samples. They bring it over to our testing laboratory where there's a hot fridge where the samples get put in, and then we barcode them into our system, and then we go to the first step with the heat inactivation step, and that starts the lamp assay procedure.
And how long does the lamp assay procedure take to complete?
So from start to finish, we working with the NEB technical team, we did some minor changes. So we extended the amplification time to 35 minutes. We did the 95 degrees Celsius incubation for 12 minutes. So those little changes puts us at about 40 to 45 minutes from start to finish. If you just did an individual sample, of course, we did them in batches of 24 at a time to avoid any cross-contamination. So most of us and the technicians, we can run through a batch in an hour. So a 24 batch in an hour. And so we had multiple overlapping samples being done at a time. And in a full day, we could run through 1,000 lamp assays.
Wow, that's pretty impressive.
The barcoding really makes a difference. You avoid error from handwriting numbers, and information. Again, we went with the 24 sample number to allow less of a risk for cross-contamination or mishandling samples. The other added change we did is if a positive came back, then we would repeat that and perform it in triplicate to confirm that it indeed was positive by the lamp assay.
Interesting. And so, what's the frequency with which a lamp assay in triplicate is returned positive and then followed up by an RT-qPCR assay that's also positive? Or have you had instances where a negative result has then been returned by the RT-qPCR?
Right. So we know more on the lamp positives and how they come back from the NP compared to lamp that was negative because we really didn't pursue those any further during the crisis. So early on with our partner, there were some issues with the NP PCR detection. And once we improved that and switched to another provider, greater than 90% came back in concordance with the lamp assay.
Wow, that's pretty high agreement.
It is. Not all the positives in the lamp assay were confirmed by the triplicate running of lamp assay, and usually that was related to pH. So we would see the change in the colorimetric readout, and so we would either change reaction volume or introduce more stabilization buffer to neutralize the pH, and that usually rectified the false signal.
Understood. So how long has the program been in place?
We developed a multi-layer surveillance program late summer to have it implemented in August. And so it's still in place. So we started in August to get baseline signals through the wastewater surveillance program. And so that first or second week of August, I guess, would be the official start. And then the first time we deployed and used the lamp assay, I believe, was the first or second week in September.
And you've been continuing monitoring ever since?
We have until the early warning signs indicated that we were on the verge of a major outbreak. And so based on the wastewater surveillance, lamp assay, and NP confirmatory results, we ended up moving to a fully remote campus in late October, early November. And that was in part thanks to the lamp assay surveillance.
Wow. So the assay and the surveillance system that you had in place really let you know that you were on the verge of a major breakout on the campus?
Correct. That's correct. And we've overlaid the data with the available county information on the incidence or rate of COVID-19 in Monroe County.
Mm-hmm.
And our surveillance program, if you overlay the data, completely predicts that there was going to be a major upswing and uptick in the county. And so we provided that information at a consortium, which the county is part of. And so it's been pretty exciting to work in this consortium and share information real time so other people can be alerted.
Yeah, that's very interesting. So when the school went fully remote, does that mean that students are still on campus in campus housing, or were they sent home to their respective states or countries?
The college administration decided to go to remote, and it happened over a 24-hour period of time. So it was pretty acute and rapid. But those students that were positive remained in their isolation, so either on campus or at other area locations that the college had contracted with. And they had meals and healthcare provided for them during their COVID isolation period in case they got really ill. We want to make sure they were fine. So we didn't send any students home that were positive. All other students that showed negative were free to go home and finish the semester out remotely. So we didn't want to send the virus back into families' homes or get their grandparents infected. So that was a real important step.
Absolutely. And so, do you consider that a success in terms of being able to monitor and contain the infections?
Yes, many of us do. We're uh, located, near on the outskirts of Rochester. Our address is in Rochester, but we're really in a small village just east of Rochester. So we felt like we protected the surrounding communities as well as the campus community based on the surveillance program.
Yeah, it sounds like you must have. Are there other institutions that are using this surveillance method?
So there is a consortium for the wastewater surveillance detection, and a lot of the other institutions struggled on what to do with the next level of surveillance and then testing. And so we were again sharing openly what we were doing. I know one other institution in the area was picking up to do the lamp assay. A few others chose not to do it and do pooled saliva and send it out to a third party provider. The reason we chose, and I think the other institution chose to do the lamp assay, was the accuracy and simplicity of the assay, but also it put our destiny in our hands. What you find is once you send samples out, you no longer have control over those samples and the turnaround time and getting the data. So we can turn this information around within 24 hours thanks to the lamp assay. Other institutions have found out even if they send out pooled saliva samples to a third party provider, either another university or college or a company, it could take 2, 3, 5 days. And at that point, if you're on the verge of an outbreak, you're already in the middle of it by the time you got your data and it's too late.
Yeah, absolutely. Certainly, speed and accuracy are both important factors in being able to effectively surveil a situation.
We feel the major advantage of having the lamp assay is that it did put our college campus community and the destiny in our hands. So the ability to conduct the detection rapidly and accurately and provide the data within that same day to the college administration to make real-time decision making was very powerful. So in our case, it allowed us to prevent a major widespread outbreak and protect our campus and the surrounding community. And so I think others have heard that from us. And so that's why they're interested in the LAMP assay as a powerful tool as part of their surveillance program.
Is it important to be able to access that data yourself? For instance, you mentioned that when you do see a positive LAMP test result, you repeat it in triplicate. That's probably not something that would be done by a third-party testing solution provider. So what's the value of that, and what's the value of sort of having that control of your own data, of your own population's data?
Yeah, I think the power really is in having control over that population data that you've produced and can verify. And those individuals could be moved into quarantine while the validation is done by a CLIA lab for the NP detection. Uh, some institutions, organizations decide to save some money and do the pooled saliva. So they're pooling 10 or 12 individuals in a saliva pool or a floor of students. And then if that comes back positive, then they would test each individual. But again, each time you do that, you're adding on minimally 24 hours to 96 hours. And so in a situation of a pandemic, time is crucial. So the quicker you get the data and the more accurate it is, and it's in your hands and you can rely on it, the better.
Yeah, that definitely seems to have been effective in your case in being able to shut down the potential of a large outbreak of infection. Do you recommend that other institutions start to adopt some sort of surveillance testing, especially advanced education systems where there are large communities of students coming from lots of different areas, bringing those potential viruses and also interacting with each other more frequently? Do you feel like we should have surveillance systems in most major institutions or in all major institutions moving forward?
Yeah, I would hope so. For institutions, higher education, military, any large congregate, settings, I think the multi-layered surveillance program is effective. It's the new sort of canary in the mine shaft, right? You can do an early alert system. So if you have the capability to do the wastewater, you get it at the population level. If you could deploy something like the LAMP assay or the LAMP assay that can specifically detect the microbe in a very timely and accurate manner, that is very powerful. And of course, this is the current coronavirus pandemic. There's more to come. There's obviously influenza, seasonal and sometimes more severe. So it would be nice to see these deployed more frequently during these outbreaks. And I think it has a very powerful way to protect the community with these early detection systems.
If listeners are interested in learning more about the surveillance system that you have set up there at St. John Fisher College, is there a good resource that they could go to online to learn more about what you all are doing there?
We don't really have, I think, per se anything online for the surveillance. We are trying to put together a manuscript right now. We are part of a joint manuscript that's been submitted from the consortium that's under review, and so that'll be out there to share with people that are interested. But if they just reached out to us, we're happy to share our experience, both with wastewater surveillance, LAMP assay, and how combined they're highly effective.
Absolutely. And we'll keep our eyes peeled for your publication as well and be sure to link to it in the transcript of this podcast.
And one, the benefit is actually working with NEB. The technical support group were very responsive, immediate to our discussions, how we can tweak it for our needs. And so that really allowed us to be fluid in improving and adapting to our circumstances. And I can't say enough about the NEB technical team.
Oh, thanks so much. I know our team, the loop-mediated isothermal amplification team, as well as the teams that work on PCR and RT-qPCR, have been working really hard with institutions all over the world to help bring more options for testing and diagnostics and surveillance monitoring to different parts of the country and different parts of the world. So thanks so much for remembering our technical support team, because they're definitely putting in the long hours and doing their best to work through solutions that are going to help communities stay safe and avoid outbreaks.
Yeah, and that has a real world impact. I mean, we're familiar with how great the reagents are with NEB for research purposes, but it really has been a pleasure to work with the team and the quality of the LAMP assay for the purposes during this pandemic.
Thanks. Yeah, we're definitely honored to be part of the solution to moving forward from the pandemic and being able to better monitor individuals' health moving forward. Thanks so much for sharing the story of the surveillance testing at St. John Fisher College with us. And thanks so much for all the work that you're doing in spearheading the surveillance program there and the LAMP testing that you're doing on the individual samples as well in your lab.
Oh, thank you very much. And thank you to NEB for having a real impact for our safety here.
Thanks for joining us for this episode of the COVID-19 Researcher Spotlight Series. Join us next time when we shift gears a bit and begin a series focused on synthetic biology. Our first guest will be Dr. Claudia Vickers of CERO in Australia, where she leads CERO's SynBio FSP research and development program. to expand Australia's synthetic biology capabilities. During the pandemic, Claudia was involved in setting up the Synthetic Biology Australasia Group, which has been actively encouraging small gatherings and Zoom talks among the SynBio community.